Hi, we are Group 4 from CS1114D. In this video, we are going to explain the topic of logical equivalence for subject MAT222. Enjoy!
Hi, my name is Asha Masira binti Khairul. My matric number is 2020843356.
Hi, my name is Nur Hawahana Humaira binti Muhammad Shukri. My matrix number is 2020617336.
Hi, my name is Najih Habita Zulkifli. My matrix number is 2020494427.
Hi, my name is Siti Asha binti Almanizam and my matrix number is 2020894604.
Hi, my name is Hanis Maisarah binti Hanafi and my matrix number is 2020824498.
Before we get to know more detail about this subtopic, let me give an explanation of the introduction of logical equivalence. The definition of logical equivalence is proportion P and Q are logically equivalent if P biconditional, Q is a tautology. In this subtopic, you have to know these three definitions. The first one, what is tautology? A tautology is proportion that is always be true. Next, contradiction. Contradiction is proportion that is always be false. And the last one, a contingency. Contingency is a proportion that is neither a tautology nor a contradiction. Then, it denoted by P is logically equivalent to Q or can be written in a symbol that has shown. Next, if P is logically equivalent to Q, then the statement P and Q have the same true value. Last but not least, it states that the equivalence of P and Q can be established by constructing truth table for both statements and then comparing the two.
Statement in logical equivalence. First is tautology. Tautology is a statement that is true under all possible true-false variations of its propositional variables. That means we can assume that when the statement that has given shows all three in the truth table will become a tautology. Thus, for contradiction is when the statement is false under all possible true-false variations of its propositional variables, which means that it will show all false in the truth table for the statement that has given. And for the last one is contingent. For contingent, the statement that has given will show both. Some is true and the other will become false. Let's look at the example. The question asks to construct a truth table for the statement as given. State if the statement is tautology, contradiction, or contingent. So the first step we have to do is by split the statement in small statements so that it will become easy for us to find out the answer and then fill in the truth table with each combination of truth value in P, Q, and R. Next, for the second step is fill the truth table for each of the statement with truth value and the complete statement which has been gathered from a two combinational statement that I have highlighted, which is in statement 3 and 6. Now, we already can find out the answer. As we can see, since the truth value for the statement that is given are all true, then the statement is tautology.
After that, I will explain about conditional statement. A conditional statement is an if-then statement, where some condition must be satisfied to reach some conclusion. A conditional statement has a hypothesis, which is the if part of the statement, and a conclusion, which is the then part of the statement. It has three conditional statements, which are converse, inverse, and contrapositive. The converse of a statement is when the hypothesis and conclusion are switched. The inverse of a statement is when the hypothesis and conclusion of a statement are both negate. The contrapositive of a conditional statement is formed by negating both terms and reversing the direction of inference. Let's go through with example 4 about conditional statement. Given the statement, if it is my birthday, then my mother will buy a cake. The question asks to find the converse, inverse, and contrapositive. For the first step, we have to define our P and Q so that it will be easier for us to change to any conditional statement that we want. Let's say our P is it is my birthday and Q is my mother will buy a cake. So, as for converse, we just have to switch the position of P and Q from if P then Q to if Q then P. So the answer will be, if my mother will buy a cake, then it is my birthday. Next, the inverse of the conditional statement is if not P, then not Q, which is we have to negate both P and Q. So the answer will be, if it is not my birthday, then my mother will not buy a cake. Lastly, the contrapositive of the conditional statement is we have to negate the both P and Q and reverse the direction for P and Q. In other words, it will be if not Q, then not P. So the statement will be, if my mother will not buy a cake, then it is not my birthday. In conclusion, every statement in logic is either true or false. The most important part when we want to do this kind of question is we have to know what is our P and Q and also know how to define each of the conditional statement. Thank you.
Next, I will proceed to example 3. The question asks us to use truth table to determine whether A or B and C is logically equivalent to A or B and A or C. The first step to solve this problem is to identify all the variables from the given statements and find the truth values. First, from these statements, we can identify 3 variables, which is A, B, and C. So that means we have 8 possible truth values, which is true, 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 false, true, false, true, true, false, 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 true, true, false, true, false, 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 true, and false, false, false. Next, we can divide these statements into parts, which means to derive a smaller statement from the original statements to make it easier to find the final answer. We have B and C to help find the true value for the first statements, and we have A or B and A or C for the second statement. Next step, we can proceed to fill in the true values of other statements. From these statements, we can see that there is an AND statement, which will only be true when both of the variables are true. There is also an OR statement. It will be true if either one variable or both variables are true. You can fill in the true values for the rest of these statements according to these rules. Finally, we can see that since the true values for both final statements is identical, which is true, 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 false, 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 therefore these both statements are logically equivalent to each other. Hence, A or B and C is logically equivalent to A or B and A or C.
Let's proceed to the last example. For this example, we need to use the truth table to show whether the statement above is tautology or not. What is tautology? Tautology is statement that are true under all possible true-false variation of its propositional variable. So from all the above statement, we need to see whether all the truth value in the last statement is all true. The first thing that we need to do is fill the truth table with 8 combination of true-false value in A, B, and C. Start with row A. From top to bottom, we fill with true, 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 false, 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 false. As for B are true, true, false, false, true, true, false, false, and proceed to C, true, false, true, false, true, false, true, false. Then we need to do the first equation, which is for A and B, which is true, true, false, 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 false. Then check the implication of A and B with C. To check for the implication, the hypothesis need to be true and the conclusion need to be false to get the true value false. We can see that only row 3 has a true hypothesis and false conclusion, and we get the true value of false there. The other true value for column 5 is true because it doesn't have a true hypothesis and false conclusion. We need to fill the truth table with true value for the second statement. But first, we need to fill in A, B, and C naught value. Start with C naught, false, true, false, true, false, true, false, true. For A naught, false, 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 true, 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 true. And lastly, for B naught, false, false, true, true, false, false, true, true. Then, find the truth value for A or B naught. For A or B not, we get false, false, true, 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 true. After that, find the implication of C not with A or B not. For this, we also get false follow 3 because the C not, which is the hypothesis, is true and A or B not is false, and all the other value is true. Last, we check whether all the statements are a tautology or not by checking the implication of a statement with the second statement. There is no true hypothesis and false conclusion from all the statements, and we can conclude that all the statements have true value of true. Since all true value for implication of A and B implication C and C not implication A or B not are all true, then the statement is tautology.
From what we see from the example that my friend explained just now, it concludes that if a conditional statement has the same true value as its contrapositive. We say that these two statements are logically equivalent. We also see that a conditional statement is not logically equivalent to its converse and inverse. Logical equivalence can be applied in many situations in our daily life. Next, logical equivalence between two sentences can be a matter of the form of the two sentences, not just what they are about. And last, the explanation makes us understand more about logical equivalence. I hope this video will help you to understand more about logical equivalence subtopic. That's all from us. Thank you.
Here is the list of references that we've used in this video. Thank you for watching. Bye!